Hello everybody. Well, by now you've done your first team investigation. And what have you learnt? Have you learnt more about electricity? Have you learnt how to connect things up so that the lights are going to glow? Hopefully you've cottoned onto the key word, which is circuit. We need to create a circuit so that the light gets the energy from the electrons and lights up. Okay, so they're the basics, but we need to design, or you need to design with your team, a set of fairy lights that has not been designed before. You're going to come up with it. And so I guess another question we could ask is, if we're going to design a set, then what materials would be best for us to use? You know, should we use wood in our circuit? Should we use plastic or rubber? What sort of materials are going to be the best type of materials to use as we put together and design our circuits? And you probably already have some ideas about that, and we're going to test them in this next investigation. Now, one of the key differences here is that you're not going to work together in your team of 4. You're actually going to work in pairs for part of this investigation, for the first part, and then on the second part of the investigation you're going to do some thinking by yourself. And Mr. Burns and I are going to assess you on your thinking and on how well you conduct your investigation, come up with your hypothesis, and draw some conclusions, make some applications from that investigation. So, it's important for 2 reasons. 1, it's an assessment, but 2, you're also going to learn something that you can use, some valuable information, hopefully, that will help you to create your fairy light design. So, materials. Okay, here's a bunch of materials that I've collected. They're just everyday household items that you might find around the home. They're all made of different substances, different materials, and you're free to come up with a way to test them with you and your partner. But first think about maybe which materials do you think are going to be the best type to use. One particular item that you'd be familiar with, of course, is this. I've got a quick question for you. What do we call the grey stuff that's inside the pencil that we write with? If you just answered the word lead, okay, you're half right. People call it lead because it used to be made of a substance called lead, but we realise that that's a dangerous substance, so they've changed the substance now. It's called graphite, but we still call it a pencil lead. And guys, when you test this, you're going to test not the wood that's around the outside of the pencil, you're going to test the lead or the graphite that runs inside the pencil there. So that's why you can see this pencil's been sharpened at both ends, okay, so that we can actually test that graphite, that lead substance, to see whether we might use it in our investigation and in our fairy lights. Guys, the scaffold that you're going to use for this looks a little bit different to the last one you've used, so I'm going to take you through it now and give you some tips on how you can best fill that in. Here we go. Alright, so this is what the scaffold looks like. It looks a little different to the one we did last time, but it's pretty similar. Okay, there's a spot for your name and date at the top. And we're calling this investigation What Conducts. We'll talk about what that means in a minute. Okay, so the first 2 boxes you're going to need to fill in on your own. The first thing is the problem in question. Okay, state the problem you want to solve or the question you are trying to answer. Now, once you've done that, you need to come up with a hypothesis. So there's 2 questions here to answer. What do you think you know about materials that conduct electricity? And conduct means to allow it to pass through. What do you think you know about those materials? What sort of materials do you think allow electricity to pass through? But here's the key. You've got to also explain why you think this is so. And you don't have to be right, but this is your hypothesis. This is what we're going to try to test today. All right. Now, can you see that in these 2 boxes here, the second box is worth 2 marks and the first box is worth 1 mark. So that tells you sort of how much you need to write for each of those. Now, once you've done that, you can get together with your partner and you can plan an experiment. Okay, Now I've already put down the materials that you're going to have to be able to use. You can use all of these materials, would be my suggestion. We've got 3 wires, battery, light bulb, and then you've got all these things over here, the CD, the pencil lead, etc. All of those things are in that little bag that I showed you before, which this one here, which has all the bits and pieces in it. Okay, now you're going to need to think about a label diagram. Draw a label diagram to show how you will connect equipment and test the materials, and you're going to do that in this space down here. Okay, you can work with your partner to work that one out. Then here it says, what is the variable? What is the one thing you will change in this investigation? Remember, we want to keep everything else the same except for one thing. That's called the variable. Okay, and then when you test each material, what will you look for to show whether it conducts? So all of that whole section there, the plan and experiment section, if you look down the bottom of the box there, it's worth 4 marks. Okay, that goes over the page there. That whole big box there that goes over the page is worth 4 marks. Right, prediction. Look what it says there. Do not write anything in this box. I might take a little mark away if you write something in that box because you're not supposed to. That's what it says there. Instead, it says make your prediction for each material in the table below. Do this before you conduct the experiment. Okay, so here on the left-hand side, this is our results table. And here we're going to put objects in, so we might put lead, oops, like that, smaller, lead from pencil, okay. Now we might make a prediction about whether we think it's a good material and whether it's going to work or not. We might say, yes, we think it's going to work. What did we observe? We're going to say, well, that's what you have to work out. And was it a conductor? Yes or no? Okay, well, we haven't tested it, so we don't know yet. But that's how you're going to use that table. Guys, make sure you put your predictions in this column, okay, before you test them. That's really important because otherwise you won't actually, you might not actually learn very much if you don't do that. Okay, down the bottom here underneath the table, were there any results that you did not predict? Okay, so if you find something there that you didn't predict, then make sure you write that down. Guys, this table here, plus that question there, is all worth 5 marks. Okay, and obviously you and your partner can work together to make sure you fill that one in properly. But that's where you have to split off from your partner. The last 2 sections you're going to think about and work on by yourself. The conclusions, so what can we conclude from the results we have? Could our hypothesis be correct, yes or no? And why or why not? So you're going to have to think about that carefully. That's worth 2 marks. And then the application section, I've got some questions which I think relate to our fairy light design and relate to the investigation that we're doing today. So I'll let you read those questions yourself when you get up to that point. And you can see down the bottom here that it's 6 marks in total. So each answer, there are 6 parts of those questions, and each answer is worth 1 mark, so 6 marks altogether. Total marks is 20. And guys, that's all you need to know, I think, at this point. So best of luck. If you've got any huge questions, you might want to talk to me or Mr. Burns before you conduct, or as you're conducting your investigations. Go well, guys, and enjoy the science.